I'm just going to quickly show you how to check a few things on your models. First of all, if what you've used as feature engineered are important. Here you can run the importance plot from random forests, and you see, surprisingly enough, that for my model in that predicts the Brazilian stock, the first few important features are all Korean based. So the Korean market seems to have quite a large impact on giving some value to my to my Brazilian trading strategy. So that's somewhat interesting. And then you have other series. You'll see that the feature engineering we've done is actually quite helpful, because we can see the different frequencies with the moving averages getting introduced, and also the difference, the long-term difference. We are predicting 3 months changes, where it looks like the actual quarter-on-quarter difference backward is having some sort of importance in our model. That's a good way to try and see what the model means, and if you can maybe fine-tune it more. Obviously, if we run it on the XGBoost model, we will have something roughly similar, but it's not exactly the same. So that's also something that is of not noticeable, is that the order of importance is slightly different. So the first one is still Korea, but then we have the dynamics of US versus Asia, the change in its moving average, and then we have Mexico, and then we have the Nasdaq. So it's slightly different set of features. So maybe what we can do to go further is to take the 10 top features from our random forest and the 10 top features from our XGBoost, mix them together and try to have a new model and see if the results are better. But for now, I'm just going to run quickly a new model that is going to prune. So I'm just going to go back to the importance here, and I'm going to take the first 10, basically, the first 10 of them. So basically, what I'm trying to show here is, are we able to reconstruct only with 10 variables the same results that we had using 820 variables? Long story short, the answer is yes. Actually, you can have exactly the same, or almost the same accuracy with using only this number of features. So it's important to first try it all, like have a numerous number of features, and then you can reduce it to make your model more fit for purpose, and then you're going to be able to train it much more faster, which means that you can implement it in a strategy and be able to be more nimble and retrain it maybe more often, and capitalize on that.
There's something I wanted to add. First, thank you very much for this great presentation, Hervé. I think it was very instructive. On the last point that you were mentioning about feature engineering, also a good practice or something interesting to do is, when you go into a direction using your feature engineering, for example, adding lags or combining or dividing features one with each other, what you can do is each time you do it, you run your model and you check what's your accuracy. And you can see that some type of feature engineering will have much more effect on your accuracy. And in general, this is the direction you need to push towards to eventually find the right set of features for the model.